This is the second mini-lecture for section 5.2. Now let's talk about subtraction of integers. So just as for whole numbers, subtraction of integers is defined as a fill-in-the-blank addition problem. So if a and b are integers, then their difference, a minus b, is the unique integer c, so that a is equal to b plus c. So when we ask what is a minus b, that's the same as asking b plus what is equal to a. For example, suppose I were to ask what is 4 minus negative 3. Okay, that's equal to what? Well, what I'm asking is negative 3 plus what would give me 4. Okay, these are the same problem. Okay, I'm really trying to fill in this blank. And if you think about it, you'll see that this has to be the number 7. So it's really an addition problem. So that means that 4 minus negative 3 is 7. So notice I'm not doing any of the tricks that you learned in algebra class. I'm not, canceling out the minuses and writing a plus or anything like that. Okay, those rules work. They're fine. But that's not how this is defined. And we need to understand the definition before we start using the tricks. Let me try another one. Negative 2 minus negative 4 equals what? Well, here we're asking, negative 2 minus, negative 4 plus what would give you negative 2? And the answer to that is 2. So this is 2. Or I could do something like negative 3 minus 7 equals what? Well, that's the same as asking 7 plus what would give you negative 3. And the answer to that is negative 10. And so here we're using the actual definition of addition. Okay. In reality, though, it's a little bit easier, as you probably know, to think about subtraction as takeaway. And we're going to do that with colored counters. Subtraction with colored counters works using the takeaway model. So for example, let's think about negative 7 minus negative 5. Okay, well, I need a representation for negative 7. And the easiest one is the 7 white counters. Okay, so that's negative 7. And I'm subtracting negative 5, so that means I want to take away negative 5. I want to take away 5 counters. See, I'm just literally taking those away, just like we would with whole numbers. Okay, what's left over is 2 white counters, but 2 white counters represents negative 2. So the answer here is negative 2. Okay, let's try another one. 5 minus negative 2. So let's begin with the simplest representation for 5, positive 5. Now I want to take away negative 2, so that means I want to take away 2 white counters. But that's a problem because I don't have any white counters here. So what I need to do to solve that problem is use the fact that this is not the only way to represent 5. Right? We saw in the last section that each integer has many different representations. Okay, I could, instead of having 5 black counters, for instance, I could have 7 black counters and 2 white counters. See, what does this represent? Well, it still represents 5 because the 2 white cancel out with the 2 black. So this is still 5. But with this representation, I can take away 2 white counters. And that leaves me with 7 black. So the answer here is 7. Okay, so let's do one more kind of similar to this. Let's use colored counters to represent the difference. -7 minus 4. So let me start with 7 white counters because that's the easiest way to represent 7, or -7 rather. Okay, so 7 white counters. I want to take away -4. I want to take away 4 black counters. But this representation does not have enough black counters. So I just need a representation of -7 that has enough black counters to take away. The easiest way to do that is probably to use 11 white counters and 4 black counters. See, 11 white and 4 black, what does that represent? Well, it still represents -7. Same thing. But now I can take away the +4. And that leaves me with -11. So I really think colored counters help illustrate what subtraction of integers means better than anything else. Now, we do have this rule that I know that you learned in algebra class or sometime like that, junior high. At some point, you've learned that a minus b is the same as a plus minus b. A different way of putting it, but it really means the same thing, as you could say something like a minus c is equal to a plus c. It does really say the same thing. So why is this true? Well, it's not a matter of multiplying by -1 or anything like that. We have to think about what these two sides mean. Okay, the right-hand side is an addition, the left-hand side is a subtraction. A subtraction is a fill-in-the-blank addition problem. So this equation is saying that this thing right here, this a plus minus b, fills in the blank. So let's check. Okay, this is the proof of the theorem. If I do b plus a plus minus b, well, I can rearrange things using the commutative and associative properties. To write this as a plus b plus minus b. But b and minus b are inverses or opposites of each other. So this is a plus 0, which is a. That means that this a plus minus b fills in the blank. B plus blank equals a. So therefore, a minus b is a plus minus b. Because I just showed that this item fills in that blank. So let's talk about mail time stories. Subtraction with mail time. Okay, here's the 4 possibilities. If they bring you a check, that adds a positive number. If they take away a check, that subtracts a positive number. So you're losing the check now. If they bring a bill, that adds a negative number. If they take away a bill, that subtracts a negative number. So if you send off a bill, that means you get money because you're telling someone else, this is what you owe me. So for example, the mail carrier brings a bill for $8 and takes away a check for $15. Are you rich or poor, and by how much? Okay, well, we'll pause here and think about it. And I mean that literally. Pause the video for a second and think about it. Okay, so the mail carrier brings you a bill. That means you're losing money. They also take away a check. That also makes you lose money. So both of these transactions are making you lose money. And so that means that in all you're going to be poor. You know, both things make you poor here. And it's by 8 plus 15. So by $22. Notice I don't try to put a negative here, right? The poor is the negative. Okay, but this represents negative 8 plus negative 15 equals negative 22. Okay, next. The mail carrier brings a check for $19, takes away a bill for $7. Are you rich or poor, and by how much? So they bring you a check, that makes your money go up. They take away a bill, that also makes your money go up. So both of these things are making your money go up. So you're going to be richer by $26. And this represents 19 minus negative 7 equals 26. Okay, and you know, it's the same result as if we had done 19 plus 7. Okay, same answer, but the story would be different, right? So it's really important when you write these on your own that the story match what's happening, or what's supposed to be happening. If there's subtraction involved, then your story needs to have something being taken away. So for example, let's write a mail time story for the difference, negative 9 minus negative 5. Be sure to state the answer. Okay, I could rewrite the problem as negative 9 plus 5, but that wouldn't be what I'm supposed to illustrate. So here I could say, you know, the mail carrier brings a bill for $9 and takes away a bill. See, it takes away, that's the subtraction, for $5. Are you know, etc. I won't write the whole thing out. And the answer here is that, well, let's see, so he brought us a bill, so we went down $9. Sent away a bill, we went up $5. So in all, we are poorer by $4. So we lost 9, we gained 5. So we're still down by 4. Okay, last but not least, let's talk about subtraction with the number line. Okay, on the number line, subtraction is represented by putting the arrows head to head. That's really important. The arrows need to represent the numbers. So for instance, let's do 4 minus negative 7. Okay, 4 minus negative 7. So start with the 4 arrow, 0 to 4. And then I need a negative 7 arrow. And it needs to be head to head with the 4 arrow. So it means I'm going to have to count up 7 units, which gets me to 11. And I have an arrow pointing from 11 to 4. and that's the negative 7, and the answer is the 11. Okay, if you'll go back and look at how subtraction with the number line worked for whole numbers, you'll see that we're doing the same thing that we were there. It's just that the numbers can be negative now. Okay, so let's also illustrate the difference, negative 9 minus negative 5 on the number line. Okay, so we begin with an arrow representing negative 9. Points from 0 to negative 9. Now I need an arrow representing negative 5, and I want to place it head to head with this arrow. So again, I'm going to count up 5 units. That gets us to negative 4. And there's the negative 5. And here's the answer. Negative 4. Okay, so the homework exercises are provided for you, and we'll discuss them in class.